Welcome to Factoring Quadratics, Day 2. I had the title Factoring Trinomials last day, just because of the questions that we were trying to tackle had three terms to it. So it would have the ax squared plus the bx plus c. But I'm calling today's lesson Factoring Quadratics, because this is the equation for it's a quadratic equation. But sometimes you'll find that maybe the middle term is missing, or one of the terms is missing, so it's not considered a trinomial, which is three terms. So you could have a binomial. So if you're wondering what's going on, I'll scroll to one later on here. There it is. Okay, so here there's a couple terms, so binomial in a sense, but you can factor it just like you've been factoring it with everything else here. Okay, so for the first bit of the video, I'm just going to do a quick review. Hopefully you're at the point where if you know it's a simple trinomial, you can do the quick trick method. But otherwise, I'm just going to go over these two methods again, just because I always find that students always need another day with factoring quadratics to get really good. So from there, if you wanted to, if you're feeling confident, you can jump to the part of the video when I get to activity 2 here. Oh no, not activity 3. Okay, because I'm going to teach you some new tricks here on how to factor. So you learn decomposition and area model, but I'm also going to teach you the Australian method and the guess and check method today, so that you can pick up some more tools and decide on using some tools over others. Or if you are happy with the decomposition method or the area model, then you can stick with those as well. Okay, so start at the beginning here. So the simple trinomials. I'm not going to label things on assessments where like these are the simple trinomials. Okay, go factor them. You need to be able to recognize that, oh, the a is equal to 1. There's no number sitting here, so it's equal to a is equal to 1. And so I can use that little quick trick method where once I find the factors in the product sum table here, I should be able to go right to the answer. Okay, so let's start here. Okay, so we are looking at the sum of the middle term, b term. Okay, so that's 8. And then we're looking at a product of 12. Okay, so 1 times 12 is 12. Okay, both positive. All right, so again, hopefully you've practiced enough that you can come up with the two numbers really quick. Okay, but when in doubt, list them all off. Okay, and don't worry about the signs at first. 1 times 12, will it add or subtract to 8? Nope. So then we go to 2. 2 times 6, yes, that'll make 8. Okay, so 2 plus 6. So I'm not going to sit there and list off the other ones because we found the two that work. All right, because we know that this is a simple trinomial, we know that the answer will be x plus 2, x plus 6. Okay, and you can use this, it doesn't matter which method you guys are using, if it's the area model or the decomposition model. This trick here with the simple trinomials, as soon as you find the two terms, you can go and put them right in the brackets and that'll be the answer. Okay, but if you do need to see the two methods here, we'll go through the decomposition method right from scratch. So we're going to write the x squared again, but we're going to decompose the middle term into the two numbers we found, 2x plus 6x plus 12. Okay, so from there, you are going to divide out a common factor of the first pair and a common factor out of the second pair. Okay, so look for numbers, look for letters. All right, and then from there, factor out those common factors, write what's left. Okay, and then this step here, you should always get those two factors looking the same. Okay, and then from here, remember, these two are the common factors here, so you can just factor that right out. So like, hopefully you see that this and this, they have both of these in common, so I'm going to factor it write it right there, and then what's left? X. Oops, the X and the 6 are left. Okay, all right, but again, hopefully you can get to the part where you just build this table, you see the two numbers there, boom, right to your answer. Okay, all right, for students that want to see the area model, so I'll come back and do those actually. I'll just keep going with decomposition. All right, keep going here. So we are now finding the product and sum of 11 and 30. Sum of 11, product of 30. Okay, all right, so again, try to think of those numbers really quick. The two that would multiply to 30, but add to 11. Okay, so I'm just writing them all out. 4 doesn't work, 5. Yes, the 5 and 6 work. So if you add them up, you'll add up to 11. All right, so again, use your trig method. You know it's a simple trinomial, so you can quickly write the answer. Okay. And, oh yeah, and then I'll just show you one more here. So if you want to see the whole decomposition method. Okay, so I'm taking the middle term and decomposing it into 5 and 6, which are the two numbers I found from my sum and product sum table. Okay, from there you're going to find the common factors, factor them out. Okay, and then you get to your final answer. All right, so I think maybe after a couple of decomposition methods there, you could see what you need to do for decomposition. Why don't you try the trig method as you go down, okay, with these ones here. Okay, so go ahead and work ahead with. So I'm gonna do the area model ones now on this side. So again, you need to write your A term here and your C term here. Okay, and then you need to figure out what to put in these other boxes that are empty. Okay, so again, we're going to fill in these boxes here by looking at our sum product table that we created here. So we found that 2 and 6 work, so we're going to add those numbers into these boxes. Again, it doesn't matter where they go. Okay, so 2 can go there, or the 6 could go there, etc. But just put one in each. All right, and then again, the box is already full, so you're going backwards. You're trying to factor out. You're going to take a number and divide it out. So what can divide out a 2x and 12 here? So hopefully you see that a 2 can divide out. And the greatest common factor for the next row here is an x. And above, we have x squared and 2x's. We go down the column here. So x works there and 6 works there. Okay, and then so when you pop out your answer, you will get, so you're writing what's on the outside. So x and it's a positive 2, so you write plus 2, x and a positive 6 plus 6. Okay, and that's what you got over on the other side as well. All right, so next one, same thing, looking at the question. A goes here, the C term goes here. Okay, from our product sum table here, we found that 5 and 6 will work. So fill it in. And then factor out the common factors, the greatest common factors. Okay, and the order that the factors are written doesn't matter. So you can write x plus 6 first, or you can write x plus 5 first. Still the same. Okay, so now that you've seen the two methods from last day again, try to use the little trig method with the simple trinomial. So just build your product sum table. So we have a sum of the middle term which is -2. Okay, pay attention to the sign. And the product is -15. All right, so again, if I wanted you guys all to watch that second video I made last day because I was trying to make factoring a little more efficient. So what I was showing you guys there was I was getting you to, when in doubt, list off all the factors. So 1 and 15. I know that we have to multiply to -15, but we're just not going to pay attention to the sign right now. We're trying to multiply to 15, but we have to add to a value of 2, okay? Well, -2, but again, we're not paying attention to the signs right now. So when we take the two numbers, 1 and 15, the quick check that I want you to do is to add them and to subtract them. If you can get to a number 2, that means you have the numbers that you need. You just have to tweak the signs. Okay, so right now 1 and 15 don't add, don't subtract to 2, so that is not one of our possible values that we need here. So then we just go to the next one, 3 and 15. Okay, so if I add them, I'll get 8. If I subtract them, I could get a 2. Okay, so now I'm going to tweak the sign. So our goal here is to get -15. So I need to make one of these negative in order to get -15. So again, if you could think of it using your head, then do that. But if you find that just writing it out, thinking about it this way works better, then do that. So I'm going to write both possibilities out. The -3 could be negative. The 5 could be negative. Okay, but now if I go to add them up, which one is going to give me -2? Okay, so this one here where the 5 is negative. Okay, will give me the -2, but when I multiply them, it'll give me the -15. So, and again, I know it's a simple trinomial, so I can use the trick method here and go right to my answer. I don't have to use the whole decomposition method or the area model. Okay, so that's where I would like you to be at today. Okay, and if you're watching this going, well, what are we learning that's new? You're going to just see some more complex ones below. So that's why you can skip a bit ahead if you're feeling confident, but it's always good to try these as well and get lots of practice. Okay, so this one here is -8 and +7. So again, think of all the possibilities, because sometimes just think of all the possibilities, and sometimes there might only be one set of values that will work, okay? So you're thinking, okay, well, 1 times 7 is, those are the only numbers that multiply to make 7, okay? So you're thinking, oh, how's this going to work? Okay, so if I add or subtract them, can I get 8? Yes, I can. But here's the condition. We need to have a +7 and a -8. So how do we get there? Well, the other possibility here is that you can have -1 and -7, right? We'll multiply or add to -8. Okay, all right. So again, simple trinomial. That's a 1, and that's my 7. Okay, and same thing. It's almost like a third method, right? It's a simple trinomial. You can just jump right through to the answer. You don't have to do the decomposition or area model. Okay, all right, and what did you notice is that you would, so if you did this for the first time, hopefully you would have noticed that, oh, when you found the numbers from the product sum table, oh, those were the actual factors. Okay, so we can write that in. So the factors, when I say that, that's the final answer here. Okay, so the factors can be found using the product sum table. And I don't know, some of you might wonder why I say product first, just because I guess I find the product, and then I go find the sum, even though I don't write it in that order. And I guess some people have told me, why don't you write it in a different order? I don't know. I guess I've always done it this way. So anyway, you guys can do it whatever way you want, as long as you know you have to get the product first, then find the sum. Okay, so now that you've seen the trick method, I want you to just go and try these ones here really quick, and then check your answers, and then we'll move on to activity 3. Okay, so here are the answers. It didn't matter. Like in the end, if you don't want to use the trick method because you just want to know one method, like if you want to just use decomposition on everything or area model and everything, then those work fine. But if you want a little bit of a shortcut, as long as you know that this is a simple trinomial, a is equal to 1, you know you can just find the two numbers through the product sum table and then just write the factors here like this with the x. So if it's a positive 3 and positive 7, you write x plus 3, x plus 7. If it was a negative 4 and a positive 6, this is what you do. You just write x, then go write negative 4, so minus 4, x plus 6. And again, if you were trying to figure out if you know you did that correctly, there is a quick way that you can check. So just make sure to write check, so that I know that like this answer here is your final answer, and then you can do a little check on the side or in a box separated. So just say this is my check, and then so you just got these two as your factors when you factored the expression, and then so a way to check it is just to FOIL it back in. So check using FOIL. Okay, so, or I'm going to show you area model next as well. So again, FOIL means you're going to take the first, multiply with the first. So that's x squared. Then you're going to take the outer 2, okay? And that becomes 9x, positive 9x. Then you're going to take the inner, those two, and then you're going to take the last, which is this one and this one. The last one's in the binomials. Okay, so then clean it up. X squared, 11x, 18. So again, this is our check step. And if you take a look, the original question was x squared plus 11x plus 18. Okay, so that's how you know you did it right. And this is the way that you can check that you did it right. So just make sure, right, check that you're checking it over here. So I know that this was, the x plus 2, x minus 9 was your final answer. And then you know that you were just checking it to make sure you did it right. Okay, so I guess I've had students in the past where they just ask me for an extra sheet of paper and they do all their checks on a separate sheet. And then that way it's not messy and it's not messing up their test. So. Okay, if you wanted to know how to do it with the area model method, this is how you can do it as well. Okay, so again, you wanted to check that you got, so we'll use the same question here. So you want to check that the answer, the factors that you got, x plus 2, x plus 9. Okay, so you wanted to check to make sure that was correct. So this is what you would do if you wanted to use the area model. Okay, so you draw your squares, and then you're going to take your factors, write them down the sides. So you're going to go x plus 2, so plus 2 goes there, x plus 9 goes over here, and then now you're just multiplying into the box there. So if you are looking at, so for this top box here, you need to take x times x. So what does that make? That makes x squared. Okay, so the one beside it, x times 9x. So you have x times 9 becomes positive 9x, and so forth. X times 2 is 2x, and then last box, the 2 times the 9 makes 18. Okay, and then we always write our our final answer outside of the boxes here. And remember to add these up here together as one. And you get 11 x plus 18. Okay, so again, you got to the original question, and that's how you know it's a great way to check before you hand stuff in. Okay, all right. So from there, let's move on to, so we just did a bunch of simple ones. Let's move on to now the complex ones. So again, this is still review from last day. It's a tricky concept. It always takes a few days to, a few lessons to get it, a good hang of it. So can you make sure, try these ones now, the complex ones. And so I'll put on a page here. So what you're going to do here is now a is not equal to 1. It's equal to some other value, so you need to make sure that you are not using the trig method anymore, okay? You could do it above, but not here. So what you're going to do here is I'm going to teach you 4 different ways to go about doing this. And again, if you find that one of these new ones you like using it, then go ahead. Okay, so again, we are in a scenario, it's complex, so a is not equal to 1. Okay, so step 1, look for your GCF, which I should have had you doing above, but step 1, look for your GCF. Okay, is there anything? No, just the 1 would work. Step 2, some product sum table, so the sum of -7, the product of 10. Okay, so remember you're multiplying the A and the C, so 2 and the 5 makes 10. Okay, so again, get to the point where you can think of all the factors in your head really fast, okay? And to the point that you don't even have to write this product sum table. So if you can think of actually the factors in your head, you can actually get to the guess and check method, which we'll come up to, okay? All right, okay, 1 times 10, 2 times 5, oh, 2, okay, so again, I wasn't putting the signs on, but I couldn't add 1 and 10 to make 7. I couldn't subtract them, right? So this was no, but then the 2 and 5, I can add them to 7. So we know we have the right numbers. So now we just got to tweak it. So 2 plus, like positive 2 plus positive 5 doesn't make -7. So the other scenario is I can take the negatives, both of them negative, because that'll make positive 10, but it will also add up to -7, okay? All right, so we're going to use the decomposition method. I'm going to give myself a bit more space here, and you're going to go through the steps and write all the steps out. You're going to break up that middle term. So again, just so the question's together, write it out here again. You're going to decompose the middle term. So write the first one. The middle term will now become the 2 numbers that you found in your product sum table, and then your C value. Okay, and then you're going to factor by grouping, and then also, yeah, take out the all numbers and letters. That'll work here. And the second group, okay, so see how the first one here is a negative. So remember, you always get then divide by negative, and they both have a 5 in common. Okay, and now we can factor them out. The 2x comes out, leaves an x. 1, the -5 comes out. Oops. I made a mistake up here, so let's fix that. I should be dividing both of these by -5, so then I get a -1. Okay, and then from there, last step. Okay, they have this one in common, so let's factor it out, and then that leaves these 2 behind. That's the other factor. Okay, so that's the decomposition method. Okay, let's try the area model now. So you still go through the same steps as before. You look for a GCF. Okay, and again, reminder above, I forgot to do the GCF, but they were all 1, but always check this first. Okay, you do the product sum table just like you did with decomposition. Okay, and then say we went through all the factors and we figured out those two work. So then you are going to create your area model. Okay, so the A term goes here, the C term goes there, and then the two values that you found for your product sum go in the other two boxes. Okay, and then from there we need to find the factors. Okay, so if I'm looking at the first one here, so that I have my -2 here. So since you have a negative value, you have to take out a negative. And then what do they both have in common? The numbers don't work, letters don't work, so you got to write something, so write 1. Okay. All right, the next one above, 2x squared and -5x, is they don't have a number in common, but they have an x in common. Okay, and down the column here, so they both have a 2 in common and an x. And again, here's another one that's negative, so -5 comes out. All right, and then we get to our answer, write the factors that are found on the outside of the box. And there is the area model method. Okay, so some of you might kind of compare the methods that right there, decomposition and area, and think, oh, okay, well, area model is not bad. It's a little bit less writing. That's what some people might want to use this one sometimes. And but again, I understand if you just want to learn it one way and no other, not multiple ways. Okay, so let's move on to the Australian method. Okay, I was actually at a session once where there was actually an Australian teacher at it, and she was like, "It's called the Australian method," because she's never heard it before. So anyway, I'm not sure why it's called this, but me and an Australian found it. Okay. Anyway, so this method is like, I had a student once ask me, I like formulas. I like being able to do things with formulas. So this is kind of a formulaic way of, I guess, solving. Yeah, quadratics. There are other formulas as well, but we'll get to those ones eventually. But if you don't not really liking decomposition, not liking area model, here is another alternative, and then we'll get to the guess and check method. Okay, so step 1, look for your common factor. Okay. Your GCF, and if you don't see one, and then move on to the next method. Okay, so GCF. Okay, it's just a 1, right? So now what you want to do here is you don't do the product sum, but you think of what's the value of A. Okay, so remember A is the number right here. So A is 2. Okay, all right, so if you like the formulas, you have to memorize this formula. I'm not going to provide 2, so if you want a formulaic way of solving these factors, this is the one you need to memorize. I'll explain what the letters are in a sec. Or I guess, never mind, you still have to do product sum. Okay, so anyway, but you don't have to do decomposition and draw a box and so forth. So, all right, so A is, so again, the number here, and then the T1 and T2 are the terms that you get from the product sum, okay? Product sum values. Okay, so if we do that right now, so I'll do it in a different color here. So we need this, the sum of -7, and we need the product of 10. Okay, so again, so say we went through all the factors, and again we found that the two values that work are -2 and -5. So that's going to be your T1 and your T2. Okay, so that's T1 and that's T2. Okay, so X is just like the X that you would normally see in the factor in the final step, right? So, all right, so go through and fill in the formula. All right, so we have A, which is 2, X, and then you have plus the first term, which is -2. I'll clean up the signs in a sec. And then we have A times X plus the second term, which is -5. Again, I'll clean up the signs in a sec. All divided by A, which is 2. Okay, so if I go through the steps and clean up the signs first, I would have that at the top. And I'd have that there. Okay, and then from here, you can see that the value for like the one on the left here, I can divide a 2 out of both of those. So almost think of it like having 2x minus 2 divided by 2 like that, and then also having this over here on its own. Okay, so if I divide a 2 out of both of those, I'll get x minus 1, and then I'll have my other term still, and then I get to my final factored answer. Okay, so anyway, just there are other methods out there, so if you're not liking all three of these, keep looking around. There was something, yeah, there's lots of different other methods. So for now, I'm going to teach you the guess and check method. I would like you to actually try to get to this method in the end, because it just takes a lot of just kind of thinking about it in your head, calculating the numbers out in your head, and then getting to the answer quickly. Let's move on to the guess and check method now. So we are going to still go through the first step of finding the greatest common factor. Okay, so the GCF. Okay, there's no numbers that you can divide out that you can think of, right? And there's no letters that they have in common. So the only thing they have in common is 1. All right, so now you want to go and get into the guess and check method. So the first step here that you're trying to look at here is the a value is 2. So I want you know that the factors will have a form like this. There'll be 2 sets of brackets, and then they start with an x like that, and then there might be a number in front of the x, but there will be a number after that's added or subtracted to the x. So if we think of a is 2. So all the numbers that multiply to make a, 1 and 2, that's it, right? So the first 2 in the brackets here, they have to be 2 and 1, okay? Those are the only possibilities, because you have to get them to multiply, make 2x squared, okay? So if you were doing FOIL, you would get 2x squared, okay? All right, so then you're going to look at the C term, which is the 5, and you're going to think, okay, so all the numbers that can multiply to make 5. Okay, so this is a nice, easy question, because only 1 and 5 work, okay? When you have lots of different factors, then you have to kind of cycle through all of them, and then at that point you might think, oh, maybe the decomposition method takes about the same time, but if you can kind of cycle through the factors really quick, you should be able to get through, guess the answers. So I have 1 and 5, so I'm just going to put them in here, 1 and 5. I'm trying to just guess to see if it'll work. So right now I'm going to quickly do FOIL. So the first one, 2x times x is 2x squared. 2x times the outer, so 2x times 5 is 10. I'm not going to write the signs in right now, but I'm going to write 10x, right? And then 1 times x is 1x. And then the last one is 5, okay? So without even doing the last FOIL, the last step, you can kind of look at the 2 here, and it's kind of like the product sum in the sense that I can't add or subtract 10 and 1 to make 7. So I know that this is not the right combination here. So I'm going to write a no here, okay? Okay, this is not going to work. So we'll try another one. So again, we know 2x and x have to start these off. So we just got to figure out the last 2. So let's not give up on 1 and 5, but let's change it around like that. Okay. So again, quickly do FOIL. 2x squared, yep. 2 times 1 is 2x. 5 times x is 5x. And again, now can I combine these to somehow make 7? Yes. So that's how I know I have the numbers that I need. I just now have to tweak the signs. Okay, so again, you have to decide if one's positive, one's negative, and so forth. So right now we have a positive 5. So that means what numbers multiply to make 5? Well, 1 and 5 or negative 1 and 5. That's what we got to decide on here. Okay, so, well, remember what do we have to do? We have to take those two numbers and add them to 7, okay? Or sorry, these two numbers add them to 7. So if I, for example, let's just put a negative and negative in, okay? So you're going to get 2x squared, then 2 times negative 1, so that's like negative, and negative 5, and then the last step, positive 5. So this is how you know you did this one correctly. So again, I always put negatives in first, and then I'll change one to positive, okay, or change them both to positive. So in the end, it's just another way to do it. It's called the guess and check method. So this one worked. So you'd say, yep, that's your final answer there, okay? So it's about just throwing factors in, checking it like by multiplying out to see if you get back to the original, and you might find that it's a lot faster than doing these other methods like decomposition and Australian model and stuff like that. So again, I'd like you guys to actually get to this method in the end, so that you're fast and you can come up with the factors really quick. But it takes practice. Like go through and practice all these other ones, and then every few of them try to just guess, try to just throw the factors in and see if you can just kind of build this last step really fast without doing all the extra stuff like the tables and so forth, okay? Okay, so here are 4 new complex trinomial questions that you can try. I have 4 of them, so that way if you wanted to try all 4 methods and see which one you like, you can do that. All right, so I'm going to go through them as well with you, and yeah, and if you are finding that you get it, go ahead and try activity 4. So I call it the powered up section, because there's some trickier ones where, oh, there's letters on the C term now. Okay, so can you still handle that? And there's some that are only a couple terms, so what do we do then? And yeah, like a couple terms, and then there's some that have 4 terms. There's like, you know, Z to the 4. Okay, so let's just see what we can do there. And then yes, just keep in mind that if you know you've done everything, you checked all the factors, there's nothing that'll work, okay, then you can write cannot be factored. All right, so let's start here. So I'm going to go through a little quicker. So I'm going to do decomposition for this first one here. So again, step 1, GCF. Anything work here? Nope, just the 1. So I'm going to take the sum of 11 and the product of 18. Okay, so I'm thinking 1, 18, 2, 9. Yes, there we go, 2, 9. Okay, break up that middle term. Okay, and go in groups here. Factor in groups. Okay, an x can come out of both of these guys. And this one and this one, 3 works. Okay, oops, red, all right, whatever. So that leaves us with a 3x plus 2. And this one, a 3 comes out and leaves us a 3x plus 2 as well. So that's the common factor to pull out here. And that leaves an x plus 3 behind. Okay. All right, that's decomposition. Should I write that here? Decomposition. Okay, so I'm going to do area model for this corner. Okay, so step 1, GCF. Nope, just a 1. All right. Product sum. Okay, so you're thinking 1 and 20. Nope. 2 and 10. Oh, that would work. All right, so our conditions are we need to have a negative 20, so we need one of these to be negative. And again, I'm just writing them all out just because you're trying to learn this right now. But if you don't need to do that, even if you don't even need to come up with a product sum table and you can think of the two factors, that's awesome. Okay, that's like guessing and checking in a way, so that's good. All right, those two, I need a negative 8. This is the one that's going to give us a negative 8. All right, so those are the two that we're going to use to break up that middle term. So we're going to write positive 2x, negative 10, minus 5. Okay, and factor by grouping. Okay, 2x come out of both of these. And, okay, so watch out, this is negative, so negative 5 has to come out of both of those ones. Okay, and factor away. There we go. Same factor came out. So let's write it. And what's left? These two in brackets. Okay, all right, so there's our decomposition. Let's try the Australian method now. Again, not sure why it's called that. I had an Australian teacher tell me she's never seen this method before. So anyway, Australian. Okay, so this is the formula one. Again, you need to find or actually let's find the GCF first. Double checking. Nope, we're good. Okay, A is 1. So now the formula, so let's do product sum as well. Sum of 25, the product of 144. Okay, so big one, but you can handle it. Okay, all right, so if you can't think of the two numbers, just go through and divide, keep kind of finding all the factors, dividing them out until you know that you can add or subtract to the 25 value. Okay, so this was 3 and 48. Okay, 5 doesn't work. 6. 7 doesn't work. 8. 9. Okay, that is going to add to 25. All right, so we just got to tweak the signs. So I'll just go towards Pikachu here. So we need a positive 144, so the positive 9 and positive 16 doesn't work. So if we take the two negatives, that'll work. All right, so remember this is the Australian method. So this is your first term, that's your second term. It doesn't matter which one you label which, but and now we have our formula. So AX added to the first term in brackets, AX added to the second term, all divided by A. Okay, plug it in. So A in this case was 12. I don't know why I wrote 1. 12. And X, so I'm just going to clean up the signs right away. Minus 9. 12X minus 16. All divided by 12. Okay. All right. So from here, I'm going to just factor the ones at the top. Okay, so I'm going to take the 12 and the 9, and I can see that they both have a 3 in common. I'm just going to factor that out. Okay, this is where it's probably going to be like, oh, this method takes too long, but just, give it a chance. All right, the next one, 4, they both have a 4 in common, so I'm going to pull that factor out. Get to there. Okay, and then do you see how the 3 and the 4, they can multiply to 12, so really they can cancel out with this 12 here. And your final answer is that method there, okay? Or that answer there. Okay, so last one, we're going to use the guess and check method. But as usual, we should start off with just checking for the greatest common factor. Okay, 7, 19, 6. Okay, greatest common factor is 1. There's no x's that can be divided out either. All right, so from here, guess and check. So we're not going to use a product sum. Well, in a way we do, but like we're going to just look at the factors that make up A and the factors that make up C, and then try to wing it from there. So we'll start with A. Separate here. Okay, so A is 7. So what numbers multiply to make 7? So A is 7. What numbers work here? Like 1 and 7. So again, this is what you're just doing in your head. All right, 1 and 7. Okay, those are the only ones that work. So that means the first values here have to be 1 and 7. Okay, so if I go 7 times x, that makes it 7x squared. So far so good. That's what I want. Now we're going to look at the C term, which is -6. Okay, but we're not going to stress about the sign right now. Okay, but we know it's -6. But right now we're just thinking all the numbers that make 6. So 1 and 6, 2 and 3, etc. Okay, or I think that's it. So yeah. So you're just going to throw the numbers in. Okay, you pencil them in. Okay, so let's try 1 and 6 like that. Okay, so if you quickly in your heads, like I know I was writing the answers down here in the example, but this is what you're doing in your head. 7 times x is 7x squared. Okay, so that's good. All right, so then from here, outer, 7 times 6 is 42. Right, so in your head you're thinking 42, and then the middle inner is 1x, right? These two numbers will not add or subtract to make 19. So you know, oh, okay, this is not what is going to work. This is a no, okay? So then you're going to now guess and check another solution here. So, sorry, I'm running out of space here, but okay, so we'll start with 7x again, and x. All right, so we tried 1 and 6 here. In this combination here with the 7 with the 1, x with the 6, but that didn't work. So let's just not give up on those two numbers, but let's swap them. Okay, what if I write the 6 here and the 1 here? So again, 7 squared, 7 times x is 7x squared. Sorry. Okay, so in your head you're like, okay, that one's good. All right, so now outer, it's 7x. Okay, inner, 6x. And then we don't have to do the last one, you know already. These will not add or subtract to 19. So again, this one's a no. Okay, so let's move on to another guess and check. Okay, oops. So let's try this again, 7x. And now we have 2 and 3 we could try, right? So again, just throw them in. You'll get strategic. You'll get pretty good at this. You'll know which, like, actually that won't work, and you put it the right way, okay, as you keep practicing these. All right, 7x squared. Yep, that's good. Okay, outer, that's 21. Inner is 2x. Can those be tweaked to make 19? Yes. So we know we found the two numbers, or the arrangement that we need. Now we just got to figure out the signs now. We need -6, right, for C. So that means one of the 2 or the 3 has to be negative. So we got to figure that out. Okay, so what I usually do is I write in a negative for both of them. Okay, and if I did that, I would get a -21, -2. So 7x times x is 7x squared. 7x times negative 3 is negative 21. Negative 2 times x is negative 2. So right now, this is not going to make us positive 19. So what would make positive 19? Well, if this was a positive 21. So how do we make that positive? Well, 7x times x is 7x squared. 7 times this number 3, if I make this positive right here, plus, that'll make it positive 21. Okay, and then when I multiply these two, that's negative 2x. And now when I do the last, negative 2 and positive 3 will make negative 6, which will eventually clean up to look like this. Okay, so yes, that one there finally is the right answer. Okay, so I know maybe you're thinking, oh, that looked like it took just as much time as decomposition. I like that method better. It's like, know what to do step by step. I want to use this method, and that's fine, okay? But if you just kind of practice lots of these, you'll find after a bit that you can start guessing what these are, which order they'll go in, and so forth, okay? And you'll find that as you can kind of write down the factors really fast, you can get faster than the decomposition method or the area model, etc. Okay? All right, so there's your answer. Now go and practice the rest.